new topic, perimeter, area and volume. Across this topic there are several different areas, and there's actually more than 6, but I've broken it down into 6 main categories. So we're going to look at just area, then the trapezoidal rule, surface area, volume, composite solids, and then capacity. You'll notice that perimeter is not actually a subtopic we'll look at, it's assumed knowledge. So to start, we're going to look at finding the areas of circles and sectors. We've looked at calculating the area of a circle in previous years in mathematics. Not much has changed, however, there are a lot more ways to use the classic formula. Area equals pi r squared. We can find the area of an annulus, think about a 2D donut, like the picture there, using a variation of this formula. We can also find the area of sectors as well. The first that we're going to look at is, of course, the circle. And that hasn't changed. It's area equals pi r squared. A new one, though, is an annulus. Now, like I said, it's like a 2D donut. So the way it works is we use this formula here, where the big R is the large radius, and the little r is the small radius. When we're finding the area of a sector, we use this formula here. You'll see it's the same as a normal circle, except we multiply by the angle given by theta, and that's divided by 360 because it's a certain part of the 360. Common sectors are semicircles, where of course the angle is 180, and if you substitute that into this formula here, it will work just the same. And sometimes you can have a quadrant as well, where it's a right angle, so you can use a quarter for that. The first example we're going to look at is about Thomas, of course, and this is finding the area of an annulus. Thomas draws 2 concentric circles whose radii are 4 centimeters and 6 centimeters. What is the area of the annulus formed to the nearest square centimeter? So first of all, you can see we've used the word annulus, so that means we need the annulus formula. I've also drawn a picture of this because it's not given in the example. So we write down A equals pi, and then in brackets, big R squared minus little r squared, and then we have to substitute the values in. The first value is 6, given by the large radius, and then the second value is 4, given by the small radius. You type that into your calculator and we'll get the area is 62.83 and a bunch of other numbers. But it asks to the nearest square centimeter, so we round to 63 centimeters squared. I've used this symbol here because it's an approximate, and that gives the area of the shape as 63 centimeters squared. Second example, we're going to find the area of a sector. Find the area of a sector with an angle at the center of 55 degrees and a radius of 2 centimeters. Write your answer correct to 1 decimal place. So like normal, we're going to write the formula for a sector to start and draw a picture because we're not given one in the example. So you can see here from the picture, there was 55 degrees, it's there now, and the radius is 2 centimeters. Makes a pizza slice here. So, of course, the formula is A equals theta over 360 times pi times r squared. We substitute in those values. So we have our angle with 55 and a radius of 2. You type that into your calculator and we'll get this 1.919826. And I do the 3 dots to show that it keeps on going. Anything with pi will always go on forever. And then I have to round to 1 decimal place. So I get area is approximately 1.9 centimeters squared, and that's there 2 decimal places. So the area of the shape is 1.9 centimeters squared. And that brings us to the end of finding the area of circles and sectors. And next lesson we're going to move on to some composite shapes.